So after the Tuya Convert video, I got lots of questions on how people can do the various smart bulbs and smart lighting options. Because not everybody can install smart switches in their home due to maybe they're renting as an apartment and they can't change the light switches out, or they just don't have neutrals in the boxes and they can't install their various smart switches. So smart bulbs are the only option. So we're going to check out this smart bulb. We're going to actually put ESPHome on this one, and we're going to use the ZemiSmart 4-inch downlight, and we're going to put Tasmota on this one just to show you both options and so you can choose what's the best for your home. So let's get to it. So not every bulb is going to be the same. There's various different LED drivers that you'll find on some, say, the Walmart bulbs that you buy from there, or various hundreds of bulbs you'll find on Amazon. Why I chose these two to show you today is they utilize a LED driver called the MY9291. It's a 4-channel chip that is driven by the ESP8266. Now, this bulb is fairly easy to pop off the diffuser cover on it. Some of them are a little more difficult and you may have to pry it off, or they use like a silicone compound to attach it to it. So just be careful and don't destroy your bulb if you're just trying to look at the LEDs to determine what type of driver is inside. So let's take a closer look at this bulb. So this is a close-up of the bulb, and you may have to take a magnifying glass and look at the chip on your bulb if you're trying to determine what type of LED driver it is. This chip right here, the square one, is the MY9291 driver, and it's hard to see on the camera, but you would be able to see the chip designation on it. This is the ESP8266 chip here, along with the flash memory chip. Along the side, this one's actually labeled, and you can actually see the white LEDs. There's 2 reds, a green, then a blue, and a white, and then it continues to circle around. And these are all attached to the MY9291 driver. The downlight we're using is very similar to this. It uses the MY9291 driver, but it's mapped out a little differently than this bulb. One thing, if you haven't already done so, you need to go follow the Tuya Convert video, and I'll leave a link in the description, and flash Tasmota on your bulb. And it's very simple to do. You put these in pairing mode. Most of the time is you turn them on and off and on and off a few times, and they'll start blinking very fast. And then you'll use the Tuya Convert application to load Tasmota on it, just like you would any type of light switch or other smart device. So once you go flash your bulbs with Tasmota, come on back and we'll show you how to configure your bulbs that have the 9291 driver. So you've popped open your bulb to see what type of driver you have that drives the LEDs, and you see it's not a MY9291, or you can't find the actual driver chip due to it's covered up or it's down in the neck of the body itself. We're going to cover in another video some additional bulb types that use PWM, or we're going to cover a little different setup, the LOHAS, if I'm saying it right, LED bulbs. They're a little special setup that needs to be done. We'll cover that in an additional video, along with the mercury bulbs that a lot of people have found that you can get these at Walmart, and they do go on sale from time to time at your local Walmart if you're in the United States. This one uses a little different driver, and luckily they have built it into Tasmota, but we'll cover all this in an additional video. So let's go check out how to configure Tasmota on the ZemiSmart downlight. So the procedure I'm going to show here is going to be the same for the smart bulb and the ZemiSmart downlight. For the smart bulb, we're going to continue on past Tasmota, and we'll show you how to do ESPHome with the smart bulb. So once you get the device, after you do the Tuya Convert, and you get the device with Tasmota and you get it on your Wi-Fi, you need to go to the IP address of the device to pull up the console. If you don't know the IP address of the device, you can go look in your usually attached devices or your DHCP or IP list in your router, or you can use an app on your phone such as Fing or something like that will scan and show you all your different IP addresses on your network. So once you browse into the console of Tasmota, what I would do from the very start of things, before you do anything else, just in case you ever get locked out from changing the Wi-Fi, and issue a Wi-Fi config space 2 command. It'll make sure that Wi-Fi manager is selected. So in case there's ever an issue with your SSID or your password or whatnot with your device, it will automatically fall back into access point mode and ask you to set up your Wi-Fi SSID and password, and you won't get locked out of the bulb because there's no buttons on the bulb to do a reset. And once you've issued that command, the device may reboot and actually go into access point mode. If it does, just power cycle the light and it'll come back and be on your Wi-Fi again. So once you've done that, you need to go back, the typical things, the main menu, go to configuration, configure your MQTT broker. You can also configure the Downlight name if you like, etc. It's going to reboot each time. And then you'll notice if we toggle, the light's actually not going to turn on. So what we need to do is go to configuration. The ZimySmart light is going to actually be the AI light, which is number 27. And don't change any of the pins. That'll all change when you hit save. Give it a second to reboot, and the console will pull back up. And we're going to keep it dark because of the LEDs will end up blowing out the lens on the camera and you won't be able to see. So you should be able to, at this point, toggle the light on and change the brightness, and it might be as a white color, it might be as a purple or blue or whatnot. You may be confused that you're looking for, say, a color wheel if you're not familiar with using Tasmota with a smart light. You're only going to get the brightness and the darkness slider to go back and forth. So what we'll do is we'll go to the console, and you'll want to do a set option 17 and then a 1. And what this will do is turn on the decimal colors instead of using hex. And if you're familiar with doing hex, that's great. You can leave that option off, but most people, it's a lot easier to use the numbers. With the ZimySmart Downlight, the colors are actually in order for the AI light, which makes it easy. We can use Tasmota if we want. And so it is actually, the first channel is red, the next one's green, the next one's blue, and the fourth channel is going to be the white. So if you apply a color and say 255, and the range is going to be 0 is off, 255 is full brightness of that channel. So 255 0, 0, 0 will give us full red LED and have nothing on the other channels. Now, it may not look red, but we're going to turn that down. We'll do a 15. And we have a 15 out of the 255 for this light. Now, if we want to mix in other colors, and of course this is all at the console, and we will show later in the video on how to configure it into Home Assistant. And you can use the auto discovery method. If you want to turn that method on and pull that straight into Home Assistant, you can do it that way, but we'll also show the manual method. So what I like to do when I'm doing a smart light, I like to test to make sure all the colors are going to be in order. So we'll do 0, 15, 0, 0, and that should give us the green channel, which it does. 0, 0, 15. This should give us the blue channel, which it does. And then we'll turn off all the color channels, and we'll do the white channel, which it does. So great. The ZimySmart one is actually in order, and if we wanted to stick with Tasmota firmware, which is perfectly fine, we could stick with this firmware because as of the recording of this video, there's no easy way to map out the different channels on the MY9291 driver that's built into Tasmota. So at this point, if you didn't want to do this with ESPHome, you could actually skip to the end of this video where we're showing how to configure this into Home Assistant. Now, if you want to stick around, we'll show you how to do it in ESPHome. You can pick which firmware is the best for you. We'll actually be utilizing the firmware upgrade GUI here to send over the initial bin file from ESPHome. So in this section, we're looking at the bulb with the MY9291 driver. We flashed it with the generic Tasmota bin file, and we didn't configure it because we're just going to switch it back over to ESPHome. So first we need to go into ESPHome dashboard and build a node for this bulb. If you haven't installed ESPHome, I'll leave a link down to the bottom of how you can install the add-on for ESPHome. It's really simple, and we covered it in the multi-sensor video from the ground up of how to install the ESPHome dashboard. So in the ESPHome dashboard, you may not have these other nodes. These are the nodes that I have running in my home. So hit the plus on the right hand side, and we'll call it a name. And make sure you read the instructions that the name must be lowercase and must not contain spaces. We'll hit continue. For device type, just leave it as generic. Hit continue. This is where you'll need your Wi-Fi SSID and Wi-Fi password. Make sure and do this correctly, otherwise you will have to go the old way of having to hook up wires to the bulbs, and that may not be the option in some of these bulbs. So once you put in your Wi-Fi SSID and Wi-Fi password, it's going to ask you for the over-the-air update password to put in here. I'm going to leave mine blank. You're welcome to put in over-the-air password if you like. Hit continue, and then hit submit. Now we're going to leave the port up here at the top to over-the-air because we can't connect this bulb at this time using USB. Of course, if you did have a bulb that you were flashing over USB, which we're not in this case, then you would choose the USB port. So first what we need to do is we need to go in and we need to edit the configuration for this bulb because it's blank at this time. You'll see it already filled out all the information for you, the Wi-Fi, the logger, the API, the OTA, etc. We do need to go next, and we're going to go to the documentation and copy some information out for the LED driver in this bulb. And I'll leave a link in the description for the ESPHome documentation, but if you do search for ESPHome, you should find it through Google. So we'll search for the MY9291/9291. And we'll go to this configuration. The first thing we need to do is we're going to copy out the driver with the GPIO pins. So we'll copy this out, and we'll paste this into the configuration. For this bulb and many others, you may have to find out the GPIO pins of your LED driver. The data pin on this bulb is GPIO 13, and then the clock pin is GPIO 15. And then some additional information we need to include. If you go to the LED driver component, you'll see they talk about the number of channels and the number of chips. The default is 6. There's not 6 channels on this bulb, and there's not multiple chips on this bulb, so we need to configure these. So we'll copy number of channels. The number of channels on this bulb is 4 for red, green, blue, and white. The number of chips is 1. And now that we've finished that section, we'll go ahead and save it, close it, and just to make sure, we'll do a validate. Configuration is valid. Next thing we need are the channels. So if you scroll down, there's a sample configuration for the Sonoff B1, and we're going to copy and paste some information out of here. And you can see they're configuring here the number of channels is 6, the number of chips is 2. So what we'll do is we'll copy this out, and then we'll edit it. No point in having to retype everything out of the documentation. We can just copy examples and change it to how we need it. Go back to your ESPHome dashboard, edit the bulb, and we'll paste this towards the bottom. Now we won't have a cold white or a warm white channel, so we're going to delete this one and we'll reuse this channel, and we'll just call it output white, and we'll try the channels of red will be channel 0, channel green will be 1, channel blue will be 2, and channel white will be 3. And you may have to do this with trial and error on your bulb depending on how the channel configuration is done. And the same exact procedure will be done using the ZemiSmart Downlight if you were doing that one instead and you wanted that in ESPHome. Hit save. We'll do a validate on it. That's good. Go back to the documentation, and now you need the light section. So we'll copy the light section out. Dashboard, we'll edit the bulb and paste this towards the bottom. The platform is not going to be RGBWW. We don't have two channels of white. It's just going to be RGBW. So we'll change that. For the name, we'll call it Tuya Test Bulb 1. The red is output red as linked to here. Green is output green linked to here. Blue links to here. Now this is where we'll change. We don't have cold white. We're just going to have white. And that's going to link to output white. And then we'll delete the bottom 3 lines. We'll save it. We'll validate it. Now if you didn't watch the ESPHome sensor node I did, I had an issue with it not being able to see the bulb in the online section. So I ended up putting a static IP address in the Wi-Fi section. So I'm going to go ahead and copy that in with my static IP that I'd like for this bulb. You may not have to do this for your home depending on your router settings. So save it, close, and validate. Now one important thing, we can't upload this because we don't have it connected to USB and we don't have the over the air yet. So what you do is you click the 3 little dots here and hit compile. Now give it a second, depending on your device, whether your Raspberry Pi or some server. It may take a little bit to compile, but give it time and it will compile. So once it compiles, you should see the success message. And you'll notice the download binary button at the bottom. Click download binary and it will download the bulb bin file to your download folder on your computer. So next, once you've downloaded the bin file, we'll need to push it to the bulb. We'll go back to the Tasmota console. We'll do firmware upgrade. And we'll hit choose file and we'll browse to our bulb bin file we just downloaded. So select our bin file and we'll hit open. And then we'll hit start upgrade. Now, if you set a static IP, you will see the IP address change, and we'll just wait for it to come up inside the dashboard. So we'll hit start upgrade, wait for it to upload to the bulb. Once you get the successful message, this will time out because we're changing firmware from Tasmota to ESPHome. Go to the ESPHome dashboard, and now after 15 to 30 seconds, the bulb rebooted, and now you see the online for the bulb. Now let's go see if the colors are correct. So we're going to go to our Home Assistant dashboard because this is using the API. Go to our configuration, integrations, ESPHome, and then we'll include it in our configuration. Now you're welcome to use MQTT if you don't want to use the API, and you would just change that in your ESPHome YAML for each file. So we have our bulb, and let's test it. Now if you do get a flickering, like as shown in the top right hand corner, that is normal, and I've seen that before. And what you need to do is simply power cycle the light bulb. I'm not sure if it's something with the driver gets hung up between the different firmwares, but once you cycle the power in the bulb, it'll be fine. Wait for it to come back up, and we'll hit the brightness. So we'll try on the color wheel. Let's turn back the white value. This should turn off the white LEDs. And you can see that didn't do that. If you hit the red, looks like the white LEDs are staying on. If we go to blue, looks like we're getting green. And then if we go to green, looks like we're getting blue. So we'll need to map our channels correctly using some trial and error. So green is actually the blue. Go back to our dashboard and edit our channels. So the green is actually the blue, so that'll be channel 1. We'll change that, and so forth, until we get all the channels correct. And for this bulb, we'll set the red to 3, the green to 2. So this bulb, the white is on the first channel, then blue, then green, then red. So we'll save it. We'll hit close. Now at this point, we can hit upload. We'll validate to make sure it's correct, and we'll upload. Wait for it to upload to your bulb. Once it reboots, we'll hit stop. We'll see it's online. We'll go back to Home Assistant, and we'll turn it off, and we'll turn it back on. And now we can see we have blue for blue, and red for red, and green for green. And if we turn the white value up along with the brightness, we will see the white LEDs light up. Now of course, once you pop the diffuser back on, you actually won't see the individual LEDs like this, and it'll be like true color bulb, as so. So you can see it turns red, blue, green, we can do a white, and that's all there is to it for configuring a bulb in ESPHome. So now we're going to configure the ZemiSmart Downlight using the configuration YAML in Home Assistant, since we have the Tasmota firmware on here. One thing you'll want to do is make sure in the configuration under the MQTT you put a unique topic for this device. So I've chosen Downlight-1. Then we'll open up the configuration YAML, and I will leave a link to pull this sample configuration where you can just copy and paste it straight into your configuration YAML. First thing you'll want to do from the sample configuration is change the name to a name that you'd like, say, your living room light or outside light, wherever you install this. And then under each topic for the configuration, there's quite a few, as you can see, you'll want to change the name of each topic from my Downlight-1 to the unique topic that you chose, and go all the way down until you get to effect state topic, and there's none below that. And once you change that, just save it, and then you'll go into your Home Assistant, do a check config as always, and restart Home Assistant. So now we'll check the colors just to make sure. So we've got blue, we've got the red, we've got the green, and we can check all the colors, and everything works. We can also mix in a little white value with it to turn on the white LEDs. Now one neat thing you can do with this downlight in any other light, and using the Tasmota, if you got the effects, you can go down and choose an effect, and it will slowly cycle through the various colors on the bulb or the light. It's a cool little feature, and just let it run and it changes. So that's all there is to it. It sets you up a bulb in ESPHome. You can use a ZemiSmart 4 or 6-inch downlight. And by the way, we will be showing a future project mounting several of these in a living room in a sync configuration. So stay tuned for that. And be sure and check out their other video that we'll be doing soon, showing several other different types of bulbs with, again, ESPHome and Tasmota. They're just using different LED drivers. It may be ones that you have. So I appreciate you watching. Definitely become a subscriber if you're not already. Hit the bell icon so you can see our next video. Give us a thumbs up. Shoot us a comment down if there's something else you'd like to see, or a different type of bulb you may have a question on. And y'all take care.